Want to become an expert in networking? Looking to take your career to the next level? In this episode, we explore the first of the three pillars of network engineering, deep technical knowledge. So if you want to move beyond a surface level understanding of the core networking technologies, keep listening.
Do you want a career in networking but aren't sure where to start? Are you struggling to take your career to the next level but aren't sure the path? Welcome to Cyber Job Hacks, the podcast that gives you the strategies you need to launch and grow a successful career in network engineering. Hosted by Dr. Jeff Colburn, a solutions architect with over 30 years of experience designing and implementing large-scale networks. Each episode is built around one of the three core pillars of becoming a next-level engineer: developing deep technical knowledge, applying design best practices, and understanding technology decisions. Let's get started.
Hi, welcome to Cyber Job Hacks podcast. This is your host, Jeff Colburn. In the last episode, I described the three pillars to becoming a great network engineer, and that was that deep technical knowledge, design best practices, and technology selection rationale. Now, I encounter a lot of engineers that carry titles like senior network engineer and even network architect that are not great network engineers. So I'm going to start using a new term. I'm going to call people next level engineers. This is going to distinguish the type of engineers that I'm talking about that possess those three pillars versus those walking around with lofty titles and very little technical knowledge. So I want to make that distinction. So, and I could talk about senior network engineer and I could be talking about network architect, but it won't be talking about that engineer that I'm describing in these episodes. So we're gonna use that term next level engineer going forward. So I kind of want to break down these three pillars. We got to start with that first pillar, deep technical knowledge. So without deep technical knowledge, you can't learn design best practices. You can't design something if you don't understand it. And you can't develop that decision or selection rationale without understanding the technology, that expert level, knowledge of the technology and design best practices, right? So how you can defend technology selection and design decisions if you don't understand those two. So it's going to go, technical knowledge, design best practices, and then selection rationale, right? So we're going to start off with that first pillar. So what is deep technical knowledge? Well, does that mean you have to be an expert in everything? No, absolutely not. And those people don't exist. Nobody can be an expert in everything. But there's this core foundation that every next level engineer needs to possess. Like I call these the core networking technologies. And then there's a base that you need to possess. You don't have to know everything, but there's this common knowledge that every good network engineer needs to possess. A lot of times in the past, we just called it routing and switching, right? Even when I became a CCIE, I was a CCIE in routing and switching, right? That was the core. And what we were tested on, it wasn't, only thing proprietary at that time was EIGRP. It was pure routing and switching. And so that's really what that core networking base is. And that's what we mean by having that deep technical knowledge. We're talking about having it in those core networking technologies. So what does that mean? Well, that means you got to understand route behavior, right? How's that router going to behave? When a packet arrives to this router, what is the expected behavior? When you look at a topology, you're trying to formulate how the packet's going to flow, right? You need to understand that route behavior. And then you need to understand the routing protocols. And when I say understand the routing protocols, I'm not talking about how to configure them. That's not knowing the router protocols. You need to get down into what are these protocols doing, and configuring it'll just come second nature. If you understand the technology, you can jump on any vendor's box. Like I grew up on Cisco. I've been working on Cisco since 1995, CCIE for over 20 years, a lot of exposure to Cisco. but I know the technologies. So if I have to jump on a Juniper box, I can configure that Juniper box, right? Because I know how the technology works. I know what that technology needs to work. It's just a matter of figuring out what the commands are, right? That's the easy part, figuring out the commands. Understanding the technology and how it works, it's how it behaves and what it needs to work. Those are the things that you need to develop to have that deep technical knowledge. And that's the same like switching, right? Not everybody, you don't look for somebody to be a switching expert, but you need to understand layer two switching. And you need to know our friend spanning tree. You need to know how spanning tree behaves because as much as we love to see spanning tree go away, it's still around and you still need to understand its behavior. That's the core, right? Routing and switching, right? Those core technologies. That's that base you want to build upon because you got to build on that, right? It doesn't stop there, but that's the base from which you build from. So why do you have to have this deep technical knowledge? Personally, I never understood, someone that wants to spend 20 plus years in this industry and not want to be good, right? If you're going to do this for a living, don't you want to understand what you're putting in place, what you're implementing? Don't you want to know how this stuff works? Right? That don't make sense. So it just makes you a better engineer when you have that deep technical knowledge, and it helps you grow as an engineer because you learn new technologies. It's easier to build upon this base. Can't imagine trying to learn a new technology without having this base. It's just going to be that much harder. And to me, engineering is fun. I enjoy engineering. I love developing solutions. I love capturing requirements, coming up with a design. That's fun. That's the favorite part of my day. All right. So to me, it's fun. And I can't have that fun if I don't know how things work. So that's why you need that deep technical knowledge. That's the core from which you operate. That's the heart of being a network engineer. So how do you build that deep technical knowledge? Well, that's what I want to talk about today. And this is not just helpful for mid-level engineers, right? So you might be in industry and you're trying to figure out how do I get to that next level? This is also, if you're just starting out, like just imagine if you took this approach starting out, you'd just be crushing technical interviews. You would stand out from every other entry-level candidate who just has that very broad and wide CCNA certification. Don't get me wrong, that certification will get you the interview. But imagine if you went beyond that and you developed that deep technical knowledge, you'd kill it, right? You would be the ideal candidate. You would be set apart from everybody else. So, like I said, the earlier you start with this, the better. So what do? Well, you study the core technologies. And when I talk about core technologies, I'm talking about standard-based technologies. Don't spend your time studying proprietary. If you're working for a company and they want you to learn how to implement a proprietary solution, do that on the company dime. Don't spend your personal study time focused on proprietary solutions. You want to study on things that are going to make you a better engineer. And you need to develop expert level knowledge on these technologies. And proprietary solutions don't fall within that core technology because it's to that vendor specific. They change all the time. One proprietary solution is replaced by another one. But as you notice, the standard-based stuff doesn't go away. We're still using IPv4. We're still using OSPF. We're still using BGP. These things aren't going away. They're standards-based. They interoperate between the vendors. So this is the stuff you want to be studying. So stay away from certification exam blueprints. Firstly, they don't go deep enough in individual technologies. To develop that expert level knowledge, certification exam blueprints are not going to get you there. There's a lot of emphasis on configuration. The topics are too widespread. You're covering so much that it's only an inch deep, right? Mile wide, inch deep. So don't use that certification exam blueprint to develop expert level knowledge. You need to do something different, right? So let's take the CCNP Enterprise Core exam as an example, right? Say CCNP, you think, okay, I'll get my CCNP in Enterprise Core. That'll give you some knowledge, but it's not going to give you that expert level knowledge, right? Like look at what it does now, right? You just look at the first section. It's talking about SD-WAN and SD access. These are proprietary to Cisco. These are not core technologies, but yet you would have to study this in order to pass this exam. So you're spending time, again, on a proprietary solution instead of spending time studying core technologies. And they have Lisp listed, right? So again, you're not going to use Lisp, or you're not going to see Lisp unless you do an SD access. So again, you're using a technology that's not widespread in the industry. It's really the only place I see Lisp is in SD access. So if you look at the blueprint, it's all over the place. The only place I really see the core networking technologies is the infrastructure section. So 30% of the exam covers that layer 2, covers layer 3 and the IP services. But 70% of the exam falls outside those core technologies. Right? So how deep do you think you're going to get into the core technologies if it's only 30% of the exam? Again, if you want to get certified, that's great, but it's not going to get you that expert level knowledge. And that's what you need to, if you want to be that next level engineer, that's what you need. You need to be studying these core technologies. You can do certifications just to show the industry your credentials, but to really stand out and set yourself apart, you need to go deeper than that. Like I took the old CCIE routing and switching qualification exam. That doesn't exist anymore. They retired it. Now you use the CCNP Enterprise Core exam to qualify. Believe me, it's not the same exam. I took both. I took the CCIE written back in the day, and that was one of the hardest written exams I ever took. It went so deep. You had to know the technology. You had to know the protocols. You take CCNP exam, it pales in comparison. It does not go nearly to the level that you need to go to have expert knowledge. Actually, you would become a generalist because that's how widespread that the information is on the enterprise core. You're going everything from virtualization to proprietary protocols. So yeah, good if you want to get certified, not good if you're trying to build expert level knowledge. So what you have to do is you have to break away from certification track exams and return to how we used to study. You stop using those exam blueprints to build your study plan. You have to create your own study plan. So how do you do this? How do you build your own study plan? How do you make that break from certification exam blueprints? Well, identify the technologies you need to study, right? So, just some examples. OSPF, probably want to know that one. BGP, another one you're going to want to know, right? So just a couple, right? So you build this list. What are these core technologies that I need to learn, right? So you identify, these are what I need to study. And then you identify the resources. Now, again, a lot of certification guides out there. Don't use those. They don't go deep enough. You need to find resources that go deep. So you, like I said, identify technologies, and then it's probably going to be more than one resource to go deep on the technology. You're probably looking at a couple books. 1 hour or an hour worth of videos is not going to make you an expert in a protocol. It's usually multiple resources. Then you just study those core technologies until you have expert level knowledge. Now you can study multiple topics at once. I just wouldn't go too crazy, but you can sit there and study OSPF, study BGP, learn them both at the same time as you keep building your expert level knowledge, right? Because you're going to keep reading new resources to keep building upon. So that doesn't mean you have to stay on OSPF and then wait till you're expert in OSPF before you can start studying BGP. No, you can do multiple. Just don't go too broad, right? Just a handful at a time, I would say. And then you want to lab things up to see how it works. Now, word of caution, when you're labbing things up, this is not, just to figure out how to configure it. No, that's not what you're going to do. You're learning how this technology works. So you need to see that when you're labbing the technology. First of all, sometimes the stuff doesn't come up right away. We encounter issues. You misconfigured something. You want to understand why it's not working, because you're trying to understand this technology. So, okay, why did my neighbors not come up? Well, what is missing, or what's misconfigured? What's causing this behavior? So you're understanding the technology as you're troubleshooting. You're learning, okay, well, it's going through this neighbor negotiation. So, why did it break? So you're seeing what you're studying in action. And then once you have all that set up, don't just power down and move on. Now this is the time you want to understand the technology. You want to see it working. You want to understand how it's working. Right? Especially it's in an operating state. It's actually up and running properly, so you can actually absorb it. Like, hey, this is how it works. This is what it's doing. I'm running a bunch of show commands, really digging in. Like I'm looking at the OSPF link state database. I'm really understanding what I've been studying. I'm seeing it in action. It's not just a configuration exercise. How quickly can I build this router? No, I'm spending time. I'm kind of soaking it in, right? So that's what you want to do. The labbing is meant to complement your study. It's not just, hey, how do I configure it? No, it's how does this technology work? So what's some other examples? I said OSPF, I talked about BGP. You probably don't need to study RIP. RIP's pretty much dead. EIGRP, proprietary. You're only going to encounter that in Cisco environments. So I would not recommend it, as a core technology, unless you work in an environment and you need to use it. But again, I caution stay away from proprietary. You could add ISIS. I would start with OSPF and BGP, but ISIS, especially if you're interested in a service provider, definitely want to add that probably as the next thing after OSPF and BGP. But then even like the switching, understanding basic switch logic. I run into engineers today they don't even know how a switch builds its forwarding table or how it makes forwarding decisions. They don't understand spanning tree, or they think that if they use port channels MLAG, spanning tree goes away. No, it's still there. I'm using technologies so I don't have ports going into blocking, that I can use all my uplinks, but spanning tree is still present and you need to understand it. So again, these are things you need to add to that core networking technology. And like I said, port channeling, MLAG, these are things like how does LACP work and how does that work in a MLAG environment? So these are things you need to be studying. And then route maps, redistribution, route filtering. You're gonna want to study these things because these are the things that you're going to be using. So you kind of need to understand, well, how do I use these as part of my technology behavior? Like how do I influence route behavior by using these tools? So again, I would add these as part of your study as your core technologies. And you're going to spend more time studying layer 3, right? There's only so much you can learn about Ethernet switching, and you don't have to be super crazy expert on Ethernet switch. I ran into some people who like down to like the port costs on an Ethernet port, manipulating spanning tree. I think that's a little much because in production environments, you're not using that. Right? Nobody's manipulating spanning tree at that level. I'm not manipulating, port costs or whatever on an Ethernet switch to have it span differently. But layer 3 definitely going to be the bulk of your time, but you still have to have that Ethernet switching understanding. But if you want a more specific list of what the core technologies are, you can always reach out to me. You can find how to contact me in the show notes. I can help you build out that list of what those core technologies are. But then, like I said, you got to identify resources, right? You need those classics in your library, right? There's 2 books that I would start with, right? Jeff Doyle's Routing TCP/IP Volume 1. Great book, right? Especially for OSPF, route maps, redistribution, filtering, right? There's no better book than Doyle's Volume 1, right? And then for BGP, Internet Routing Architecture by Halabi, right? These are classics that you need to have in your library. These resources don't have to be written by a specific vendor. It just happens that these 2 classics are written by Cisco Press, but there's other resources out there from other publishers. But these resources, they're going to teach you the technology. They're not there to teach you how to configure it. There's plenty of other things that teach you how to configure it. These things will take you deep into the technology, and you'll understand how they work. And like I said, as you're studying these things, Make sure you're labbing at technologies, and it's not just an exercise on how to configure, right? It's how is this technology working? So, this is what you need to be doing, right? What's the technologies I need to study? What are my resources? And labbing for understanding, not labbing to configure. So you might be asking me, well, hey, what about the new technologies? Shouldn't I be studying that? Shouldn't I be adding that to my core technology base? Um, you will study these things, but it's not your base. It's upon this base that you're going to start studying these other technologies. Like take EVPN VXLAN, for example. It's a lot easier to learn EVPN VXLAN if you have a solid foundation in routing and switching. You'll understand what EVPN is doing at the control plane. You'll understand that the original frame is being encapsulated in a VXLAN header and then routed across a layer 3 fabric. You're going to make more sense of what what an Anycast gateway is doing, or symmetric and asymmetric routing. If you have this core foundation and routing and switching, it's a lot easier. Now, when I brief people and I do a technology deep dive on EVPN VXLAN, I can tell the people that don't have this base because they're confused. And they're not even asking me questions that are related to VXLAN or EVPN. It's more revealing their lack of understanding of basic route behavior. So you have this base. These things just build upon this base, right? I'm still routing and switching, right? And VXLAN, I just happen to be encapsulating and then routing, right? But I'm still routing. The behavior is still there, right? And then once you have this base, right, then you can start expanding in these areas, right? So maybe you want to work with service providers. So you probably start learning like segment routing or MPLS, or if you're going to spend more time in data center, and maybe you learn EVPN VXLAN. Of course, there's EVPN VXLAN applications in the service provider world, so it's probably a good technology to learn. But I wouldn't start studying it until I had that core base, that expert level knowledge in my core networking technologies. So just kind of wrap things up. I'm not saying that pursuing certification is bad. I've been a CCIE for over 20 years, and I keep it active. I'll keep it active until I retire. And it's a great way to demonstrate your skill set to the industry, right? It's still, the industry is still very focused on people having certifications, and some jobs require certain certifications. I once had a job where CCIE was in the job title. It was crazy, but it's true, right? You weren't getting that job unless you were a CCIE. But if you want to be that next level engineer, you have to study differently. So it's not about cramming for certification exams. It's about real deep study, focused study, going deep in these technologies and building that base. And then once you have that base, even passing cert exams will be quicker because you already know the core stuff, and then you just got to add all that peripheral stuff to pass the exam. So focus on building your base. You may already have a some level of knowledge in these core technologies, maybe in some more than others. So you kind of want to assess where you are with each technology. Ask yourself, do I have expert knowledge, or do I need to go deeper? Right. And then you build that study plan and you start gathering your resources. And then you may already read Doyle. So what's that next resource that's going to take me to that next level? And like I said, if you need help, always reach out to me. My contact information is in the show notes, or you can email me at cyberjobhacks@colburncareer.com. But right now, let's start building on pillar 1, that deep technical knowledge. You need to do this. Like I said, you need to do this before you start building on the other pillars, design best practices and technology selection rationale. You can't do that until you have this base, because poor knowledge equals poor design. So let's learn that technology, learn how to design it. So until next time, let's start cracking those books. Want to know more on what it takes to become a top network engineer? Be sure to download the 3 Pillars of Network Engineering. This guide will provide you a framework to move your career to the next level. You may find it at colburncareer.com or click the link in the show notes.
Thank you for listening to Cyber Job Hacks, the podcast for next level engineers. If you found this episode helpful, be sure to follow the podcast so you don't miss future episodes on how to take your career to that next level.